Writing an algebraic expression means to take a statement and translate it using a variable, numbers, and some basic operations. So looking at the top here, if we want to use addition, there's some language for that, like maybe sum or more than or greater than would indicate that you are going to add something to a variable. So for this very first one, the sum of a number and 4 means, okay, I'm going to introduce my variable, which is x, and I'm going to add to that 4. Below that, we have 8 more than a number. Same idea. You could write, I'm taking a number and I want 8 more than it, so still addition. And same thing for 6, greater than a number. So I have my number and I'll add 6 to it. So you have to just look for the language. Is it saying addition, subtraction, multiplication, or division? And then you just apply it as necessary. So for subtraction, if you want to say 5 less than a number, that means you take your variable and you're subtracting 5 from it. It would not be correct to say 5 minus x. This is saying you're taking x from 5. So just to be careful there that is not the case. But over here, 5 less than a number means you start with the number and you take 5 away from it. We're still using subtraction. So the same thing for the next couple of statements. A number is decreased by 5. That means the same thing. We start with a number and we're taking 5 away. And then a number minus 10, still same idea, subtracting some number from a given variable. For multiplication and division, there's just some other language to look out for. In this case, if you were to double a number or 2 times that amount or product are all indications of multiplication. So double a number would be twice some number, or it's still 2 times a number. And then we have this last one, the product of a number and 7. You could write as 7 times x. And lastly, we have division. So to say 1/2 of a number means to take that number and divide it by 2. Likewise, a number divided by 6, that's definitely more explicit, but take a number and divide it by 6 looks like this. So in example 1, same idea, a couple of statements here that we're going to translate into an algebraic expression. And the very first one at the top, so it's 5 more than a number. There's only 2 things really happening here. I have some number, I don't know what that is, so I'm just going to write down x. And okay, more, I think that is going to mean, okay, addition, I'm increasing it. So I'll put plus and by an amount of 5. And that's it. So 5 more than a number means x plus 5. Now for the next couple, it looks like there's more than just one thing happening. Okay, this is a number is doubled and then decreased by 4. So there's 2 things happening. I'm seeing, all right, we got doubled. I know that means, okay, I'm going to, that's multiplication. But then decreased, I know that's going to mean subtraction. But I'm still going to use a variable, x. The thing to watch out for is, when you have 2 operations in a statement, which one are you applying first? To me, when I read this, it says a number is doubled and then decreased by 4 means you're first applying the multiplication and then you're applying this subtraction. Doubled means we're taking twice the variable, and then if we decrease that thing by 4, it means we're taking this 2x and subtracting 4 away. And we can now just double check to see if we think this is right, where, okay, I have my variable, I would then double it, and finally subtract 4, and it would happen in that order. Moving on to a number is decreased by 4 and then doubled. So these two look fairly similar, but just to be careful, so we have this decreased by 4. So I'm still thinking, okay, that's obviously got to be subtraction. And then, well, we have doubled again, but I'm thinking maybe the order is going to be the opposite. And that's the way it feels when I read this statement. It looks like we're first decreasing by 4, but then the second thing we're doing is doubling. So let's see what this looks like. I'll start with my variable. To decrease it by 4 first means you're just putting a minus 4 at the very end. But now the question is, okay, I want to take this whole thing and double it. If we're doubling this whole thing, it is not good enough to just to put a 2 in front of the x, because that would only be applied to this portion here. To deal with this, I'm just going to put in some parentheses and then place a 2 outside of it. What this is doing is first subtracting 4, and we get an amount for this, but then 2, it's being multiplied to this entire amount. So it's nice to compare these two examples because it's the same operations, they just are working in a different order. And for the last one, we have half of a number is increased by 6. So I'm seeing this half, so I'm thinking division, in fact, dividing by 2. And then, okay, increased by 6. Okay, so this is definitely addition. So we have division and addition. And the order in which it appears would be, it sounds to me like we're first taking the half and then we're increasing. We should have some expression that resembles this. I'll take my variable and take half of it. I would then increase this entire expression by 6. And that's the answer for this last part. And for example 2, maybe to take these ideas and put them into the context of maybe a word problem or something like that, where the length of a rectangle is 15 inches longer than twice the width. I think I'm going to draw a picture to help me out here where, okay, I got a rectangle. And I think with the way I'm drawing it here, this would be the width, the distance of this side, and this side's going to be its length. So I don't really know if this is to scale with what's happening in the problem, but we're saying the length, so this side here, it's 15 inches longer than twice the width, which is this side. So, we have a couple of different things happening, but I think we're going to label this side L and this side W. So I was using X up to this point, but you can really use any letter that you would like. So here you could say, well, L represents the length of this rectangle and W would represent the width. So to say that the length is 15 inches longer, this to me implies, okay, we got addition, and then we have this twice the width. So I'm thinking multiplication for that. In the order, the way it's written, it sounds like we are multiplying by 2, and then to that we're adding this 15. So let's write down what that looks like. I'm taking the width, I'm taking twice that amount, and then adding 15 to it at the very end. And this is the same thing as saying the length, if you actually even just want to set up an equation. I think all that's really important here for this problem is the 2 times w plus 15, but this entire statement, now an equation, is saying the length is, and we have twice the width, and then we just go 15 more. And that is it for this example.